Hi, everyone. Thank you so much for joining me. I am Kira McLean, and I'm excited to talk to you today about Clojure for data science. So a little bit about me just to get started. I mostly write software for the internet and work with a team based out of the UK, basically helping various UK government agencies publish their data online as linked data. So most of my work is in Clojure, and that's kind of how I stumbled into this world of Clojure for data science. Was basically wondering, like, what can you do with one of these data sets that we put on the internet and tidy up and make really nice and make available? And it turns out there's a lot you can do. So basically in this talk, I'll go over a little bit about what Clojure has to offer if you have data to work with. So we'll talk briefly about what the ecosystem looks like now, just to kind of get a sense of where it's at, and then what I mean by data science and what would make a language good for data science, and talk about Clojure's current data science story, and then touch a little bit on what's coming up next and what the community is kind of working on. So just as a brief background, if you look at the most recent State of the Clojure survey, this is a survey that the Clojure team runs every year, basically just asking people kind of what they're working on and what they're working with. And you'll see the top answers when people are asked, which domains are you applying Clojure, come back mostly as things that could be described as software development. So I know that text is super, super tiny, but basically those three kind of top answers that I circled there are web development, building and delivering commercial services, and enterprise apps. So basically software development. And then much smaller numbers of people would say they are doing what I call data science or data stuff with Clojure. So those answers that are getting like 10 to 15% are math and data analysis, big data, stats, machine learning, stuff like that. So kind of broadly speaking, software development. And this shows, so if you look at the Clojure success stories, this is just kind of a selection of some of the companies that have used Clojure that are showcased on the Clojure website. You'll see that most of them are either software companies or are stories about companies using Clojure internally to build software that helps them out. And it's totally fine just to kind of lay a baseline. I just bring this up to kind of, get a sense of like where the community's at. And it's a very similar story if you look at like books or guides or tutorials that are out there. It lines up pretty closely and around like the 80-90% mark of them are kind of geared toward writing apps and libraries. So basically software in Clojure. And so there's a lot of room to grow there. I think there's a lot of people who know that Clojure is a really good kind of general purpose programming language, but may not be aware that it's also really useful for data science. And so that's basically what I'm going to talk about for the rest of the time here, and kind of covering what I mean by that. And basically, I mean that it checks these 4 boxes. So these are 4 kind of broad, I would say, requirements or ways to think about what would make a language useful or good for data science. And we'll explore what Clojure has to offer here. So by tools, I mean basically libraries. This would be this is just a brief list. This is not comprehensive by any means, but kind of an overview of some of the types of things that data scientists will need to do, or that you might want to do to your data. And we'll look at just briefly, this isn't like a comprehensive list by any means, but at the moment, Python pretty much dominates the data science landscape, and R is a really popular choice as well. But both of those languages come with kind of what I call like a complete toolkit for working with data. So anything that you might need to do, whether it's like math or crunching numbers or visualizing your data or running some statistical analyses on it, or throwing it into like a machine learning algorithm or training a neural network, all of these kind of tasks that could be described as data science are possible in Python and R thanks to all of these libraries. And these aren't necessarily like, this is not a comprehensive list. It's just to kind of give an overview of some of the more popular ways to do this stuff. But there are thousands upon thousands of libraries that data scientists use, and this is by no means all of them. But what I want to point out, and kind of the main point of this little section, is that you can also do all of this stuff in Clojure. So this is the thing that many people are not always aware of, is that Clojure also has really mature and kind of well thought out libraries for any of these tasks that you might need to do. So whether it's, the math or stats or machine learning kind of stuff, there are ways that you can use Clojure to work with your data in that way that are going to feel very familiar coming from Python or R. And most of these tools, so this is what I wanted to touch on next, was that they're pretty recent. And so that's kind of what makes this an exciting time in the Clojure ecosystem, and especially the Clojure data science ecosystem, is that we can finally kind of say in good conscience, like, you can work with your data in Clojure and you're not going to really be missing anything that's really essential. And so this wasn't always true. So like a lot of these libraries, I guess I should mention, these dates are just like pulled from GitHub as the kind of starting point of the repos. And so obviously these aren't necessarily like reflective of the actual dates the libraries were ready, or even the dates they were actually developed. But it's just to give a kind of rough idea of like the ballpark time when these libraries were mostly made. You can see they're all pretty recent, and especially the tooling situation. So for the last like probably a couple of years, the scicloj community has been exploring ways to do this style of programming that's sometimes called literate programming, which is like seeing the output of your code kind of in line. So it's like a very familiar style of programming for people who do data science, and that tooling has come really, really far in the last couple of years, and especially the support for VS Code, which is through Calva. So Calva is the VS Code plugin that lets you run a Clojure REPL. And really recently, like kind of this past month, some work has come out to support Calva notebooks, which are basically like a built-in way to run your code in a kind of notebook style, right in VS Code through Calva. And so I bring this up because, so this is a chart from the Kaggle survey. So Kaggle is like a data science platform. They host data sets and they have a bunch of data science kind of educational resources and stuff. They also run a survey every year, and one of the questions they ask is, what IDE do you use? And VS Code is really gaining popularity. So you can see like the overwhelming majority use Jupyter notebooks, which are that kind of literate programming style of IDE. But so I know this is like a lot of lines and stuff. This chart is basically just shows the growing popularity. So the relevant two bars are the ones with the arrows there, showing that VS Code is really, really growing in popularity in the data science community. So just in the last couple of years, it's gained like over 10% popularity. And now like 40% or so of data scientists say they work with it regularly. And that's really cool because Clojure has really good support now, thanks to the Calva team, for VS Code. And so having that kind of familiarity and ease of setup, I think really goes a long way, because there's nothing more depressing than like trying to learn a new language and just spending the first 3 weeks learning Emacs. So, I know there's a lot of debate in the Clojure community about how much to optimize for the beginner experience, but I do think there's a lot of value in having some way to set up an environment to get started really, really quickly and easily, even if it's not necessarily what people will stick with or work with forever. It's a really good way to lower the barrier to entry. So Calva has done an amazing job with that. And there's also lots of other tools. Clerk was on the previous slide. That's a really amazing tool that makes it really easy to get started also. And plenty of others that, sure I will wish I had mentioned after. But anyway, yeah. So basically the tooling story has come a long way in Clojure, and it's really exciting time for that kind of stuff. The next big kind of area that I think a language needs to support in order to be useful for data scientists is interoperation. So by that, I mean, in this context, I mean being able to access the existing ecosystem of models and libraries and stuff that's available for data science. So basically, there are currently like a ton of libraries and models and other tools that are already written and already exist in mostly Python, but other languages too, like R and various other languages. And it's just not going to be realistic to rewrite everything in whatever new language. And so I think it's really essential for any language that wants to be useful for data scientists to be able to interop with those languages natively. And this is another area where Clojure really has a good story. So you can call Python code or R code or lots of other languages too directly from your Clojure code, which is one option, and that's with help from these libraries that are listed there. So for Python, it's called libpython_clj. For R, it's Clojure, which I'm probably mispronouncing, apologies. But there are other ways too. So there's a whole other kind of category of tools that could be described as kind of polyglot program orchestration is kind of how I think about it. So one of those tools is DVC, which is data version control. And this is basically like a meta framework that helps you orchestrate many different steps in a process that can be written in different languages. And so that's another way to incorporate Clojure into your data science workflow without sacrificing any of the sort of more niche or essential pieces that are already implemented or already exist in like Python or R, for example, or whatever other language. And then obviously, by virtue of being hosted on the JVM in Clojure, just the last little point to mention there is that you get all of the Java stuff for free. So you can access the entire Java ecosystem, which is huge. And also useful. There's a slide later I'll show you about Java usage for data science. It's not nothing, basically. So yeah, so next, speed is going to be important for data scientists. So this isn't necessarily the most fair comparison, because it's obviously like raw speed is not often the most important thing, but it still matters. And there are still times where even if performance is not like the key thing you're looking for, it can still make the experience much smoother. And so lots of people have studied this, and obviously it's probably not a surprise that Java comes out way ahead of Python and Clojure. So Python and R, excuse me. I know I found this paper really funny. There's literally a paper called Comparison Between Python, Java, and R Programming Language in Machine Learning. So I just get a kick out of it when other people are thinking the exact same thing I'm thinking. But anyway, so they obviously found that Java is like way faster. And then this is another group that studies basically like raw programming speeds, for some reason funded by NASA, that finds, unsurprisingly, that Java is quite a bit faster. So Python are these the tall green bars, and Java is like the little burgundy bars on the right. So this isn't like super useful, because obviously you're not going to be writing like raw Python code or raw Java code to do data science stuff. You'll be using very specialized, very highly optimized libraries. But there are still times, so you'll notice like this is a logarithmic scale, and Java is often like an order of magnitude or two, or sometimes even three faster. And so, basically the takeaway is the JVM is super fast and really state of the art for large systems. And so, I guess obviously something else worth noting is that like Clojure is not Java, but there are very similar characteristics. And if it's necessary, you can write Clojure code in a way that you have access to the performance characteristics of Java if you need it. So there's a balance between like developer experience and optimal performance, and Clojure kind of, I think, strikes a really nice balance there. So it's still dynamic, it's still pleasant to write and work with, but you also get this kind of speed. And Yeah, and it's not, again, it's not always the most important thing, and it's not always super relevant, but there are times where, like, if you're talking about just 1 millisecond versus a second, you won't perceive any difference. But if you're looking at something that's like 100 times faster or slower, and you're talking about like 1 minute versus 100 minutes or 1,000 minutes, then you'll definitely notice the difference. And then those are the kind of times when it matters. So anyway, lastly, the kind of key thing I think that a language needs to have to be useful for data science is this, what I'm broadly calling accessibility. So what I mean by that is kind of the technical stuff. So being like free and open source and extensible. And those are just things that help with uptake. So there are paid solutions for stats and data science and stuff, but they're just unfortunately not as popular because of the cost barriers. But obviously Clojure checks all those boxes, but there's other also kind of less tangible things that I think are really important, like being easy to set up. So this is something that's come a long way in Clojure, like I mentioned, with the new tooling that's become available in the last couple of years. But then also other things like having a welcoming community and having a place where you can go to get help and get unstuck, where you're not going to feel like scared to ask a question. And also seeing some active development and recent progress is also reassuring for people. So like if you're wanting people to take up your tool in a sort of professional context, it's, you know, not to say like people should expect like an immediate response or to have all of their personal pet problems fixed. But people need to know that a library is kind of like actively maintained and actively monitored in order to feel comfortable using it in their day-to-day work. And then we see exactly that. So a lot of these libraries that are used for Clojure, for data science and Clojure are active and maintained, and many are backed and supported by kind of organizations that have like long-term plans to keep these libraries around. And then lastly is learning resources. So this is, I think, an area where there's some room for improvement that we'll talk about next, but there is a growing sort of body of work that's available for helping people to get started in Clojure, and specifically using Clojure to work with their data. So yeah, part of accessibility is also familiarity. And so that's what I wanted to show in this slide just briefly. This is another survey, so I'll move to the next one. This one just highlights the relevant rows. There's another organization called Anaconda, which is kind of like the self-proclaimed like home of data science for Python. So it's not surprising that Python comes out as like the most popular by far. But anyway, it's just basically another community of data scientists that they have access to, and they run a survey every year as well. And one of the questions they ask is, how often do you use the following languages? And you'll see in these answers, like Java is not that far off of R. It's a roughly like in a comparable ballpark in terms of usage. And so I think Clojure is really well positioned to be a language that people take up for data science, because it's not going to be like totally foreign. And like that's how a lot of people get started with Clojure, is you kind of sneak it in the back door once you already got Java up and running. So yeah, so basically Clojure's data science story is in pretty good shape. So we've got like all of these bases covered: the tools, the interoperability with the broader ecosystem. It's going to be super fast, probably faster than what you're working with already. But definitely speed will be a concern. And then it's increasingly accessible. So that's the last thing, is a couple points about what's missing. And so this is yet another survey, the Clojure is Together survey. So this is sort of the Clojure trade organization that asks Clojure developers what they would like to see worked on in the community. So by people who are kind of working on open source stuff. And this year, this most recent survey, the top answers come back as, documentation, IDE support, and developer experience. And so, you have to always take these with a grain of salt. Like, it's easy to, if someone asks you, like, what would you like to see improvement in? A lot of people tend to see themselves as like the protagonist of reality and answer in terms of what would make their personal lives better, as opposed to like what would make the community better. But still, so anyway, that's a whole separate thing, I guess, and a whole other issue with like humanity. But in general, it's still useful. I think there's still a lot of value in making the developer experience smooth and in having really good documentation. So, and you can see this reflected in what people are feeling is kind of missing. And so, the Cala team, the Clerk team, and lots of other teams who there's too many to mention, are putting a lot of effort and a lot of work into improving this developer experience and this IDE support for Clojure. And then the documentation side is something that I've been working on. There's also lots of other people building resources for helping people to learn Clojure and learn specifically data science for Clojure. And so it's one thing with the documentation is it's pretty, by industry standards, Clojure libraries are pretty well documented. So in terms of like API docs. So I guess one way to interpret that result of the survey, or how I've interpreted it, I guess, is there's a lack of like discoverable and practical example kind of based documentation. So the more tutorial style or guideline style. And this is something I'm working on. So so in terms of what's next, or where the Clojure data science ecosystem is kind of headed, there are several groups that meet regularly, so like every couple of weeks or months, that are focused on different topics. So there's one that's, for example, focused on statistics. There's a visual tools group. There's like a kind of a meta group, which is focused on kind of talking about the data science community and talking about the data science stack. And these study groups have brought in people who are new to Clojure. So over time, the focus of the Clojure data science community has kind of slowly been shifting toward people who are already working with data and discovering Clojure in their own ways, and finding the community seeking more information. As opposed to before, it used to be a lot more people kind of like myself, like already working with Clojure and already very familiar with software development in Clojure, and more wondering about how to use it for data. And so it's been really interesting, and it's been a really cool time to see the community kind of grow and expand into this broader kind of circle of people who are coming kind of to Clojure for the first time, and who maybe are not even necessarily software developers at all. And so, anyway, so that's kind of part of where these study groups are kind of just organically grew out of that community growth. And there's also a data science for Clojure course underway. So this is like a initiative that several people in the community are taking on to kind of put together like a series of courses or a series of talks or meetups that are going to help people get started and learn kind of the basics for working with data in Clojure. And so this is currently in progress. And right now there's kind of like we're kind of like testing out different ways of delivering it and different kind of ways of organizing the content and stuff like that. But you can follow the progress there too. And then the last thing I'll mention is the Clojure Data Cookbook. So this is a project that I recently was funded for by the Clojures Together Foundation, which I'm super grateful for. So thank you. And this is kind of my attempt to fill in a little bit of that documentation gap that the community has been expressing. So anyway, I'm happy to talk about that more as much as anyone would like later. But basically, the goal is to kind of build this like example-based collection of solutions to specific problems, as opposed to like API documentation style. So so that's that. We're in a pretty good place. So like we have the tools, we have the IDEs. We have access to the broader ecosystem, the speed, and we have a whole bunch of friendly people in the Clojure data science community who are excited to teach others how to work with all these tools. And yeah, I think it's an exciting time for the community. So I'll leave that there. But I think this ties in nicely with the theme of the conference, and hopefully we can see some more growth and some more expansion into this kind of world of people who are new to Clojure or new to software completely, but have data to work with and are curious what Clojure can offer. And that's that. So thank you so much for joining me. There's a couple links there. I know they're not like super useful on slides, but basically the scicloj website is the best place to find out more about all this stuff that I've been talking about. There's a big list of libraries, including all the ones I mentioned on the slide back there. There's more information about the study groups. I'm mostly on Mastodon now, so you can follow me. That's my little handle. I'm also available on all of the Clojurians, Slack and Clojureverse and all those places. So yeah, thank you so much for coming and for listening. And I look forward to seeing you guys around the internet. Have a wonderful day. Bye.